All right, now we're looking at question 2 here. This is coming from paper 11 that was administered in October, November 2019. And it reads, the speed of a wave in deep water depends on its wavelength, L, and the acceleration of free fall, G. What is a possible equation for the speed V of the wave? And they give you a number of different possible equations, but only one of them is actually possible. Okay, there's only one correct answer here. And if you don't have the idea of units in mind, that we can always check the sort of sanity of an equation by looking at the units and say, well, we know velocity is meters per second on the left, then everything on the right has to also be meters per second. Okay, and so I'm sure that once you know that those are different enough, right? That only one of them is going to give us meters per second. And you might like take a guess and say, well, you know, I think this one looks good, or you say, well, this one doesn't seem right, like a 4 pi squared, why, you know, what's going on there? So we kind of work through each one of them. We know that we've got meters per second on the left, okay? G is the acceleration of free fall. So remember, we're underneath the radical here, but we've got meters per second squared, and then this length would be times meters. And so, hey, I think that gets it right there, right? Because once we take the square root of meters squared per second squared, we have meters per second. So, A. And if you just go through it, sometimes, hey, the right answer is the very first one. We'd find that, like, if we didn't take the square root, we have the same two terms in the numerator, we'd have meters per second squared times meters, we just have meters squared per second squared. Right, and so that's not going to agree with this. We need a square root there. So this might be like what v squared is equal to, right? If we just squared sort of both sides of this, you see how that's sort of, so this is correct. And if you squared both sides, so that what they're missing in this one is a squared up there on the v. V squared is equal to this, so v is the square root of all of that, right? And indeed, the square root of 4 pi squared is 2 pi. And so these, you know, this kind of looks like the pendulum equation, right? The period of oscillation of a pendulum, but it's L over G, not G over L. So this would be like meters per second squared, and then the meters would be down here and they cancel out, and you'd have like the units would be reciprocal seconds. So the units of this would actually be frequency, they'd be hertz. So meters per second is not equal to hertz, right? Meters per second equals meters per second. And again, same thing here. So you'd have meters per second squared from G, and then meters down here, and you just sort of have seconds squared, you know, per second squared, not meters per second, which you need. So only choice A is possible.